Welcome to the WION podcast and to the deep dive. Okay, so picture this. You're looking down at Mars, maybe from orbit, and you see these really strange patterns. They look like giant spider webs.
Or honeycomb, yeah. Stretching for miles.
Exactly, just etched across the surface. And the Curiosity rover, it's actually heading towards a region like this right now on Mount Sharp.
That's right. It's pretty incredible. These aren't small features either. We were talking about networks of ridges. They cover maybe 10, even 20 kilometers across. Really changes your idea of Martian geology.
Totally. So our mission today, let's dive into what these things actually are and the main idea, the sort of scientific thinking behind how they formed like billions of years ago.
Okay, so the leading theory, it ties right back to when Mars had more water, specifically when the last surface water was drying up.
Billions of years back.
Billions. So as things dried out, the ground, the rock surface, it contracted and it fractured, cracked open.
Right, like you see mud cracking in the sun, but like planet-wide.
Sort of, yeah, but on a rock scale, a much larger scale, obviously.
Yeah.
So you get these cracks, and any water left, probably full of dissolved minerals by then,
Oh.
it would have seeped down into all those fractures.
And then just sat there.
Well, over time, those minerals would precipitate out, they'd harden, sort of cementing themselves inside the cracks, creating these mineral veins.
Making those veins much harder than the surrounding rock.
Exactly the point.
Right.
Much tougher, more resistant to erosion. So fast forward, a few billion years.
Wow.
And the Martian wind, maybe other processes too, they gradually wear away the softer rock all around these veins.
Leaving the harder veins sticking up.
Precisely. Leaving behind this network of raised ridges. That's the honeycomb, the spiderweb pattern we see today.
Okay, that makes sense. But we have similar things on Earth, don't we? Boxwork, is it called?
We do, yeah, boxwork patterns. But here's the difference. On Earth, you usually find them like tucked away in caves, maybe on sheltered cliff faces.
Right, protected environment.
Yeah. Not spread out across the open landscape for kilometers, exposed to everything. That's what's so striking about Mars.
So why did they survive so well on Mars, out in the open like that?
That's a great question. It suggests maybe Mars had a very different kind of erosional environment after the water vanished compared to Earth. Or maybe the rock itself had unique properties. It tells us something specific about that transition period.
Really paints a picture of, well, a very different Mars back then. And the cool part is, Curiosity is actually going there.
It is. It just finished up exploring the Geddes-Valles Channel nearby, which they think was maybe an old river channel or a debris flow.
Right, I remember hearing about that. Found some interesting sulfur crystals.
Yeah, some pure sulfur. Took a great 360 panorama too. But now its row is taking it along the edge of that channel, heading towards these web formations.
So scientists must be pretty excited.
Absolutely. Because these ridges, they're like a direct, widespread fingerprint of that ancient water activity in the drying process. Chance to see up close, confirm the theory, maybe find something totally new about early Mars.
So when you look at these vast spiderweb patterns, they're not just, cool geology. They're this incredible, visible reminder of how water shaped Mars.
Billions of years ago.
Yeah, enduring clues left behind.
Makes you wonder what else is out there, right? What other secrets Mars is keeping, just waiting for us to find.
It's a tantalizing thought, definitely.
Absolutely. Stay tuned for more such intriguing stories to come right here on The Deep Dive.